Some people can smell things that do not exist for the rest of us. They can smell sickness before any test can detect it. They can smell emotions before a word is spoken. They can smell the past in a room where nothing has happened for years. Their noses are not instruments. They are weapons, and they are curses, and they are the subject of a scientific mystery that is only beginning to be understood. The condition is called hyperosmia, an abnormally heightened sense of smell. It is the opposite of anosmia, which is the absence of smell. Hyperosmics live in a world that is louder and sharper and more intrusive than anything you can imagine. A walk down a city street is a bombardment of information. They smell the soap on a stranger's skin from across the room. They smell what you ate for breakfast 3 hours ago. They smell the cleaning product used in the elevator this morning and the diesel from the bus that passed yesterday. There is no off switch. There is no volume control. The nose reports everything and the brain must process all of it constantly. Hyperosmia can be a superpower. It can also be a prison. The most famous case of hyperosmia belongs to a woman named Joy Milne. She lives in Perth, Scotland, and she is a retired nurse. In 1982, she met a man named Les at a party. She fell in love with his smell. She said he smelled of salt and leather and something green and alive. They married and had children and built a life together. Then something changed. About 10 years into their marriage, Joy noticed that Les smelled different. Not worse exactly, just different. A shift in the chemistry of his body that only she could detect. The new smell was musky and thick and slightly unpleasant. She asked him if he had changed his soap. He had not. She asked him if he was feeling unwell. He said he felt fine. The smell persisted for years. Joy learned to live with it because she loved the man beneath the smell. In 1994, Les was diagnosed with Parkinson's disease. He was 44 years old. The diagnosis explained everything that had been going wrong with his body for several years. The stiffness in his joints and the tremor in his hand. It did not explain the smell. Or rather, the smell explained something that medicine did not yet understand. 12 years later, Joy attended a Parkinson's UK support group with her husband. She walked into a room full of strangers who shared her husband's condition. The smell hit her immediately. Every person in that room with Parkinson's smelled exactly like Les. The musky, thick scent that she had noticed more than 20 years earlier was the smell of Parkinson's disease itself. Joy mentioned this to a researcher at the University of Edinburgh. The researcher was skeptical, but he was also a scientist, and scientists test hypotheses even when they sound impossible. He recruited 12 volunteers, 6 with Parkinson's and 6 without. He asked each person to wear a clean t-shirt for 24 hours. The t-shirts were collected and placed in sealed bags. Joy was asked to smell each bag and identify which volunteers had Parkinson's. She correctly identified every single person with Parkinson's. She also identified one of the control subjects as having Parkinson's. The researchers assumed she had made a mistake. 8 months later, that control subject was diagnosed with Parkinson's disease. Joy had smelled the disease before the doctors could find it. The University of Edinburgh launched a major research program based on Joy's ability. They identified the specific compounds she was detecting in the sebum of Parkinson's patients. The sebum is the oily substance produced by the skin. Parkinson's changes the chemical composition of sebum in ways that are invisible to the naked eye and undetectable by standard medical tests. But a nose like Joy Milne's nose can detect parts per trillion of specific molecules. She is not the only one. Other hyperosmics around the world have reported similar experiences. A woman in California could smell cancer on her husband months before his diagnosis. A nurse in Australia could identify Clostridium difficile infections in patients just by walking into their rooms. A teacher in Japan could tell which of her students were about to get the flu before any symptoms appeared. Their noses were performing diagnoses that laboratories required days and thousands of dollars to replicate, and no one believed them until the science caught up. Hyperosmia is not well understood by medical science. It is not a disease with a cure. It is a trait that exists on a spectrum with normal olfaction at the center. Some people are born with it. Some people acquire it through illness or injury or pregnancy. Some people develop it as a side effect of migraine disorders. Some people wake up one morning and the world is suddenly louder in their nose than it was the day before. The causes are varied, but the experience is universal. You smell everything. Not just the strong smells, not just the interesting smells, everything. Every surface and every person and every molecule of air that passes through your nose carries information that other people do not receive. You smell the metallic tang of fear on someone's skin when they are anxious. You smell the sweetness of a diabetic's breath before they know their blood sugar is dropping. You smell the decay of a cavity in someone's mouth when they speak to you from 3 feet away. You smell the chemical residue of medications that people took days ago still seeping from their pores. The world is filled with information that most people cannot access. Hyperosmics live in a world of constant involuntary surveillance. They know things about strangers that strangers do not know about themselves. This can destroy relationships. Imagine smelling the infidelity on your partner's skin before they confess. Imagine smelling the relapse on an addict who swore they were clean. Imagine smelling the fear on a child who says everything is fine. Hyperosmics do not need to imagine any of this. They live it every day. Some learn to use the ability as a gift. Others are destroyed by it. The medical applications of hyperosmia are only beginning to be explored. Dogs have been trained to smell cancer for years. Canines can detect bladder cancer from urine samples and lung cancer from breath samples with accuracy rates that rival laboratory testing. But dogs cannot tell you what they are smelling. A human with hyperosmia can describe the scent. They can tell you what molecule they think they are detecting. They can point to the exact location on a patient's body where the smell is coming from. A hyperosmic nurse does not need a blood test to know that a wound is infected. A hyperosmic doctor does not need a scan to suspect a metabolic disorder. A hyperosmic mother knows her child is sick before the fever starts. These people are not anomalies. They are the leading edge of a sensory frontier that mainstream medicine has largely ignored. The mystery of hyperosmia is not why some people have it. It is why the rest of us do not. The human nose contains roughly 400 types of olfactory receptors. Each type detects a different category of molecules. The combination of signals from all 400 receptors produces the experience of smell. Dogs have 800 receptor types. Their noses are twice as complex as ours. But hyperosmics suggest that the number of receptors is not the full story. The difference may be in the brain. The olfactory bulb is the part of the brain that processes smell signals. In hyperosmics, the olfactory bulb may be larger or more densely connected than in normal individuals. Or the sensitivity may come from the receptors themselves being tuned to detect lower concentrations of molecules. Or it may be a combination of peripheral sensitivity and central processing. The science is unsettled because the science of smell itself is unsettled. Smell is the least understood of the 5 senses. Vision and hearing have been mapped in exquisite detail. We know which neurons fire when you see the color red or hear middle C on a piano. Smell is still a frontier. We do not know why a molecule of vanillin smells like vanilla, and a molecule of benzaldehyde smells like almonds. We know that the difference is chemical structure, but we do not understand the mapping from molecule to perception. Hyperosmia is a window into that mapping. Every person with an extraordinary sense of smell is a case study in sensory processing. They are living experiments in the upper limits of human olfaction, and medicine has barely begun to study them. The mystery of Joy Milne continues to unfold. She is now in her 70s and still collaborating with researchers. Her husband Les died in 2015. The disease that she smelled before it had a name finally took him. She continues to work with scientists because she believes her nose can help other families. She has trained herself to identify the specific smell of Parkinson's in clinical settings. She can identify the disease from a t-shirt worn for 10 minutes. She is a diagnostic instrument built of flesh and nerve and a brain that processes smell signals at a level of sensitivity that science cannot explain and can barely measure. She is not the only one. She is just the one who happened to walk into a support group in 2012 and say the wrong thing to the right researcher. She is the proof that some people live in a sensory world that the rest of us cannot enter, a world where the air is thick with information, where a handshake reveals a medical history, where a hug tells you things that words will not, where the body speaks in chemical whispers that only a few can hear. The mystery of hyperosmia is not that it exists. It is that we have ignored it for so long.